much. Okay, first of all, thank you very much for inviting me to this precious opportunity to have a presentation in your workshop at your shipping lab. My name is Hideyuki Ando. Actually, normally Hideyuki is a bit difficult to pronounce for non-Japanese, so I normally ask my family like to call me by my family name Ando, so call me Ando or Ando-san or something like that. But well, I'm working in MTI. Actually, I will introduce MTI later, but it's a research and development arm of NYK Line. And I joined MTI 2005. Before that, I was working in the University of Tokyo as an associate professor. And actually, my first job, actually, even before university, was actually I was working in shipyard. And I have actually I have several good relations with Denmark. In the beginning, when I was working in shipyard, I had actually good relation with Odense Steel Shipyard in Odense. So I stayed in Odense for a few weeks and to support the design by using by computer system. And then also, actually, after I joined MTI, we have some technical collaboration with especially Mask Maritime technology that time. So anyhow, we have I have not only those two cases, but I have quite good impressions and also good relations with my colleagues in Denmark. So I'm really pleased this opportunity. Thank you very much. And today I will talk about digitalization this and as an enabler for safer and greener shipping, based on our experience in NYK and NYK Group. And this is outline of my presentation. Actually, in the beginning, I will make introduction when I can MTI, and then we'll introduce digitalization activities. So those are, I think, quite in line with your work package one, I believe. But then from topic 3, 4, 5, actually, I will talk mainly about like a complex system and also like autonomous ships. So probably these subjects are more relating to work package 2. So if it's not the right scope for today's for your expectation today, then I'm sorry. But anyhow, what I prepared is later part is about autonomous ship. Okay, but anyhow, so NYK Line, it's a bit old company, probably one of the oldest company in Japan, more than 135 years shipping companies. And MTI is 100% owned by NYK Line, which is actually, we are running normally like 70 or 80 projects in a year. And many projects actually we are working with, of course, working with external partners, including European partners. And then, but anyhow, so we are basically running projects. Project-based work is our style of running the research. And this is a little bit old figure, but a snapshot last year of NYK fleet. So we are operating a little bit less than 800 ships. And in our case, there are actually a variety of ship type. Container ships are nowadays Ocean Network Express in Singapore are operating, which are the merger of three Japanese shipping companies to operate container ships. And then we are NYK are 39% stock shareholder of the Ocean Network company, and also At this moment, we are ship owners of container ships, and then so we are providing as a ship the container ship services as ship owners, but not as ship operators. And there's some several sizes of barrel carriers and one cruise, and then many car carriers, tankers, LNG carriers, and also several shuttle tanker business. It's a joint venture between with Norwegian company and some other offshores. So those are the brief figures of a fleet. So MTI actually we are research and development arm in NYK, but yeah, I think our probably strength is that we are very close to the actual operational fleet. So and then actually we can work with the in the with operation people and also like a marine group and then the neighbor architects and so on. So I would say, yeah, again, we are probably our strength is very close to those operational fleets. And MTI, it's this company established 2004, so 16 years ago. Actually, I joined MTI 2005. And this is a trajectory, what we have done so far. And then the upper side shows research and development projects relating to hardware. And like 10 years ago, the fuel price was very expensive, very high. So a lot of energy saving technology development we conducted. And then it gradually shifted to like LNG fuel ship, alternative fuel ship projects and so on. And also we designed some a future conceptual ship, a ship called the NYK Super Eco Ship. And so those are typical works. And also, actually, at the same time, and the bottom part is software part. Of course, that originally we started data collection from ships in 2006 and 7 because actually that time vessel performance data was only collected by null report or abstract logbook, but then it's just one data per day. So that was not enough. So I developed the data collection system from navigation side and also engine side to estimate vessel power curve and also to estimate like a wind and wave effect and so on. So actually, so we deal with data collection and data utilization. And then nowadays, actually, those data are more and more widely used in NYK MTI, especially for like engine condition monitoring and also like even sharing the data with suppliers, like engine suppliers and then those data are used for their condition-based maintenance and so on. And then, but anyhow, those nowadays probably we can call digitalization. And actually, last several years, we very much have worked on autonomous ship technical development. I will introduce later in detail, but that's to improve our safety operation. So I will quickly introduce some digitalization activities. This shows the overview what we are doing by digitalization. Of course, there are many potentials of digitalization, but as a commercial company, the value creation is of course very important. So by creating digitalization in shipping, actually this is I took idea from the analogy from mining industry. So if you have interest, please check this report. But for instance, for our shipping companies, better decisions like a deep understanding of operating fleet and market, and optimized logistics and operations, and some anticipation of failures of ships or machineries, and also incremental automation of ship functions, and monitoring fleet performance and improvement. Probably those are like for better decisions and also safer and more consistent operations. We are using operation, and those are also interlinked, like continuous learning and continuous improvement. Summarize, probably I can say that we are pursuing total optimization of operation and ship. And this is our IoT platform. We call SHIMS, acronym of Ship Information Management System. We developed this system 2008. Actually, that time our container fleet, the operation team, actually they are because of the high price of the fuel, they were demanding like micromanagement to reduce the fuel cost. But actually, they started firstly based on the noon report data, but then there are some errors and so on. So actually, and also the resolution was not good enough. So first reliability, then secondary resolution. So actually, so they came to us that how about why not to make automated collection system? So we developed this ShiMS on board. And that time we hook up the collected data to satellite communication to send shore and started to utilize the collected data. We started that activity 2008. And then actually, we are gradually expanding those data collection in NYK fleet. And then so gradually we gathered data, and then that time like 2000 around 13 14 there are kind of like a trend, the buzzword big data very much prevalent. And yes, we have sensor data, IoT data, new report data, and AIS data, and those things. And also, yes, we have domain knowledge, like engineering knowledge about like vessel performance and so on. And also, there are nice tools, gradually nice tools about data analytics and so on. So, but so actually, from technical side, we can do many things. But the problem was that actually our operation section, our business section actually could not find good possibility how to utilize data. So that we had a lot of discussion, but anyhow, the most important thing to improve fleet operation was the time we agreed that we have to identify the right issues. Like it could be relating to optimum operation, or it could be relating to support business decision, or it could be relating to safe operation. But anyhow, if the person in charge in the operation section or business section have to identify the right issues, then otherwise it is very difficult to provide good services or solutions. So identifying the right issues are always very important. And normally it is very difficult to find such a properly identified issues in the shipping companies, I think. There are some examples of how you're going to utilize the data. This is actually by combining the IoT sensor data from the ships and also the good physical engineering simulation model. And nowadays, actually, we can estimate the vessel performance in the rough sea conditions. So what we call those ship performance model in services. And by combining like weather, historical weather data, weather data records, we can run sort of like a virtual voyage. And then it's kind of like a Monte Carlo simulation, but by running that, we can estimate. This graph shows like a monthly average, like estimated sea margin or estimated like a delay. In this case, estimated sea margin or estimated additional fuel consumption. But then actually before it was like a constant value through the year. But by running those simulations, actually the business section, operation section can estimate and also seasonal impacts about how the weather affect on ship operation. And there are many other container operators also have done like 10 years ago, but we also run a lot of like optimum trim, towing tank simulation and CFD calculation, and also more than trim optimization. We also modify like valve bow or change propeller or even install energy saving devices or engine delighting and so on. Because of the after Lehman shock that time after 2009, actually the vessel speed was quite reduced, and also the cargo volume was also declining. So actually the shallower draft. So actually the original bulbous bow was too big. So we switched to the smaller ones and so on. In this case was the best case, but we could achieve more than 20% fuel consumption reduction, CO2 reduction, and so on. And we conducted similar modification on 40 container ships about, yes, that was around 2010, 10, 11, 12. And then usually, so we could collect the data, and then we expand the data not only for energy efficiency, but also like this case is anomaly detection. And this trend graph compares the exhaust gas temperature from the main engine, and then one exhaust gas value increasing comparing to other cylinders. This was caused by malfunction of exhaust valve and so on. Actually, this is a typical example, but we started this kind of data collection and analysis by our chief. Actually, we set up our big data team in the marine operation group, and the chief engineer, dedicated chief engineer, experienced chief engineer are leading that big data analysis. So with his good domain knowledge, and our data scientists are also collaborating to this, and then so they are accumulating those cases and to improve such analyzing logic, and also like a data quality management and so on. So. And since last summer, actually, they started a remote diagnostics center in Manila, Philippines. And actually, we have a college there in Manila, and then there are plenty of staff who has a domain knowledge of main engine of the ships. So actually, those staff are actually monitoring those engine condition data. We are calling it expert in the loop concept. Because of course we are using AI and some algorithms, but of course those algorithms are of course not perfect. But still, it's very it's supportive information can be provided to expert. So so by good combination by those AI algorithms and experts, then they are sorting out those the problems. And some cases they work the high priority alert case, they directly work with the inform ship management superintendent and to improve and to share the information with ship crews and so on. But anyhow, those dedicated monitoring center were developed and now in operation. And since 2016, 5 years, actually, Japanese government started 5 years research development funding scheme about utilize those IoT and then for safety. So actually, among 8 projects, actually 4 projects we are running last 5 years until last year. One is collision avoidance and autonomous ship project. Another one is structural health monitoring and the damage prevention of engine power plant and simulation of LNG cargo transport. Those 4 projects have been running for 5 years, and so, and then actually, of course, it is already, I mean, already we need the expertise inside the shipping companies, not enough. So we need external partners to utilize those data to improve safety. So we actually we changed our strategy to before actually we didn't think about to share data with external companies, but for to pursuing more to have gains from the data, we better share data with external experts. So that was actually a strategy change timing. And so we promote actually ship data center. This is actually 100% owned by Class NK. It's sort of like a neutral organization set up, the ship data center. And on that data center, we form the consortium, or what we call Internet of Ships Open Platform Consortium. And then we define the stakeholder. And we define each stakeholder, like the platform user is actually the who own the actually data collection platform. And it's many cases it equals to the ship owner itself, but some cases other entities like operator or like even manufacturer may invest to collect the data. So those somebody who believe in data and who collect the data is the platform user, and that kind of role definition we did. And then the data, and then the equipment manufacturer collect data, and the ship data center collect the store the data, and they control security and accessibility to the data. And the solution provider provides solution. And data buyer is just buying the data. And the end user is a solution user. But anyhow, those like roles we define. And then we define the stakeholders role and the data ownership rule. And the main concept is transparency. So transparency and the fairness for data sharing are important. So anyhow, we agree on some rules about that to accelerate data-driven innovation. It's now actually it's 50 more than 50 companies, and not only Japanese, but nowadays gradually some Asian and some European companies are joining. But anyhow, I think it's now more than 60 companies are participating in this consortium. So let me check. Oh, last 10 minutes. Then I will quickly go through the next subject. So as you can see, we started from the data collection, but what we are now doing is more and more like system integration. So we consider more and more ship as system. I mean, the ship is a collection of functions. And for safer and greener shipping, autonomous ship is probably a very good example. But more and more probably complex system or system of systems will be used on board on the shore, and integrity of complex system will become critical. So yes, system integration integrity is very important, and also system conformity and reliability tests will play important roles in system integration. And system failures may happen. Of course, this is a software thing, so it may happen, but they need to be properly considered and managed both in design and operation. And systems may apply AI, which will require frequent update of software programs or models. And cybersecurity, security by design and security management is one of the pillars to achieve system reliability. And I really respect the work done by BIMCO, and we learned a lot. And also we sometimes visited BIMCO house, but then to learn from Captain Aaron, but that's really helpful, and also it's really showing the great direction to the industry, I think. And this is the conceptual diagram about ship and system today. Today, this is in the middle. This is the small one, the ship, and there are independent several systems on board, and the seaworthiness of ship is assured. And then based on that, the captain, chief engineer are operating the ship. So this is actually ship operation. And then they communicate with ship management superintendent, and also a shipping company operating the ship. And then cargo owner, they also have their own system, and the port, they also have their port system and so on. And then there are person in charge. So actually they are exchanging emails or they'll communicate, but those actually systems are loosely coupled. So it's not tightly coupled. But this is the situation today. But nowadays, actually, we are gradually observing that inter-system are more tightly coupled, connected by API and so on, and also system connected like a control system even connected more tightly, so system of systems appear, and also some AI embedded. So those AI system needs like frequent update model and so on. And the vendors directly log on to the system on board and so on. So some elements of seaworthiness even rely on external maker or vendor. That is actually gradually happening. This is the situation today. So anyhow, we have to control, manage this situation. This is the big challenge, I think, for the ship digitalization. And I think now the tool for the integrity is, I think, a system integration. This is actually the example I took from the IAX Unified Rule E22 Revision 2. So vessel consists of several systems, and system consists of subsystems and so on. And the ship is considered as a group of function. Integrity of each function become more important, especially for critical functions, and the roles and responsibilities of owner, operator, system integrator, and supplier at each product phase, like from concept, requirement, design, construction, verification, and operation. At each product life cycle phase, those stakeholder has to take some role that is properly defined in rules and guidelines. Those are the current situation. And then to achieve that, actually, this is in my understanding, this is the systems engineering approach. And so, which means like this is to control this system development as similar to other industries like aerospace, automotive. We have to follow the V process for system improvement. Again, this it starts from goal definition and concept definition and requirement definition, and those are what we call like a concept of operation, CONOPS. Actually, the output from this the phase and so on. And actually, those CONOPS, concept operation requirements, quite important to run this process. And this concept of operation has to be defined by users, which means shipping companies. So those are the challenges, I think. And also risk assessment, and also like a simulation-based verification and validation tests. Those actually are the design methodology, system implementation methodology, which actually not common in shipping industry yet, but we have to deal with this kind of process. To develop shared process, methodology, tools, and standards will be the key. And yes, similar to like this is the case example I took from DNB, but dynamic positioning system test by using a simulator, and like model in the loop, software in the loop, and hardware in the loop. Those are the typical test cases. So utilization and simulation-based test is the key for productivity of system development, verification, and validation in V process. And autonomous ship as a complex system. Well, as a shipping company, our goal is not develop autonomous ship, but rather our goal is to improve our safety of ship operations. And so, we from end user's point of view, captain's point of view. Actually, myself is not captain, but I have a lot of captain colleagues. They are defining the concept of operation and so on to support their businesses or operations. So our short target is actually we consider improve safety and reduce crew workload are the target to tackle autonomous ship. And then, so yes, we believe computer complement human factor, and but still we need a good balance of people, process, technology, and organization. So not only technology, but how we're going to use technology is very much important. Maybe in the long run, we may it requires regulation change and also technical innovations, but the conditional bridge 1 operation or conditional bridge 0 operation might be possible. Well, then probably we may expect some OPEX reduction. And then in some limited cases, some full autonomous ship in very like a short shuttle operation, very small vessel, or may happen. But for deep sea going vessel, probably the practical target will be still, I think, probably conditional B1 or something. This will be the proper target for us. So we are tackling. We set our target as a manned autonomous ship. So it's an autonomous ship, but still it's supporting functions of the human cognitive task processes. This is a few years ago. We ran some feasibility study or economical evaluation, and then we believe in that the manned autonomous, I mean, human supported by computer, is still economically competitive because it reduce the incident risk and it reduce the workload, and then cyber risk will be same, but the total reliability will be improved. So that's we expect even economically that's manned autonomous could be competitive. And then some example, we run this is the tag remote operation demonstration in Japan, and the government sponsored project, and we tested some technology, and we received some approval in principle from class, and the 16 companies working together so open innovation style, and we gather diverse expertise and the share concept and the run project management, and then we could successfully ended this project actually this March. And then now we are tackling a little bit. It's a big project actually. We try to we aim at to demonstrate a autonomous navigation from Tokyo Bay to Nagoya Bay. It's about like a 300. No, it's a 200. Yeah, 200 miles, about 200 miles, but it will be in February next year. There are many subsystems, and we are running the project, and I'm sub-director of this. But of course, autonomous function itself is very important. However, I would like to enforce that through this project, we are gathering experience about the V process, which means like, again, define the operation concept, risk assessment, and model-based systems engineering, and system reliability test by using simulation and project management. So what we try to do is like, and also we try to develop open architecture and open process for open innovation for future complex system development operation. So those are the actually another target of running this autonomous ship project. And this is example of actually in this project we are using the simulator of DNB and the CyberShi and as a simulation platform. And actually, based on that, this is a conceptual configuration. Actually, this is very small to read, but the right side is autonomous functions, several systems. And then actually the left side, top is the real ship, and then the bottom side is virtual ship, I mean simulation. So there are two switch. So conceptually, when we switch from this to the other side, and also this to other side, actually, this actually autonomous function do not know which ship, virtual or real, the system connected. But that's by following those the concept, we are testing this autonomous functionality at shore side, and then in the end, in the next year, February, of course, we will switch this one to that, and then we will run this real test. But before that, actually, we are try to utilize as much as possible this simulation-based test. But and then of course we are running a bunch of model tests in model Beijing and a variety of tests, and then so reliability of simulation itself is quite important. Otherwise, actually, calibration of the parameters and so on actually are not. I mean, we optimize to the simulation ship, which is not properly. The fidelity is low. If the fidelity is quite low, then actually we have to recalibrate to the real ship. So that will, if that gap is quite big, then actually the productivity is quite much reduced. So I mean, so reliability of simulation so is very conclusion. So this is actually the snapshot from our NYK Super Eco Ship. Actually, in this case, actually we are using the liquefied hydrogen as alternative fuel, and then we are using a fuel cell, and then solid oxide fuel cell, and then combining the batteries and so on. And then, of course, this is just a conceptual simulation, but I mean, it's this kind of like alternative fuel or hybrid system. Actually, we believe that the system integration and the build process will be necessary in that kind of ship design project. So simulation will play important role in system design, development, commissioning, operation for decarbonization project. Especially combination simulation optimization will be critical in system design. And also, MTI started simulation team in April last year to enhance simulation capability. And yeah, of course, there are many challenges we have to learn about this process. And yes, it requires a huge man hours, so we have to be very productive by sharing knowledge, experiences, and good platforms as industry. And so standardizations, yes, very important. Simulation platform, simulation models, those are also very important. And education training of crews for such complex system and advanced automation system is also crucial because again, this is a people, process, technology, and operation things. And the collaboration between users and designers is also crucial to develop a practical goal and columns. So this is summary, but I will skip this. And the last message, thank you very much for this opportunity, and we'd like to seek possibilities for the discussion and collaboration with ShippingLab. Thank you very much for your attention.